Hello, all. I'm really excited to be your host at this magnificent workshop today. We're going to go through different aspects implementing AI in QA workflows. I will be your host and welcome to the QA Innovation Summit 2025. I'm really happy. So let's kick things start, and I'm going to share my screen a little bit and see our presentation. I think everything will be okay. Just give me a second. I know it will be a difficult part to do a workshop online, and all the participants follow, in a steady pace, our workshop. So I will make it as much as interactive I can. First, I'm going to start by explaining a few things about me. Yanis Papadakis. I will be your host. I'm a head of quality assurance at Snappy Bank, and our workshop is around AI. The whole conference is around AI. So we're going to discuss more how to implement AI in the modern web application world, specifically see real class examples of implementing the Gen AI to React web apps, how we can transform quality and quality processes when we are using generative AI nowadays. But before starting that, I'm going to talk a little bit about myself. I'm really passionate about exchanging knowledge through conferences. Public speaking, it's what I do in my free time well. And it's really great because you strengthen the community, and community is everything when it comes to software testing and quality oriented approach. The next, it's a very quick video just about my company that I'm working. I'm working on Snappy Bank. It's the first digital bank right now that operates in, it's going to operate actually. We're not totally online in Greece. And just a quick video. Oh, great. So that was the introduction of the company. I'm really excited to represent also my company to these conferences, and say that we like that they are helping us empower, let's say, the community. So I will start with. I need to pass the next. Okay, let's talk about the agenda now. We'll start with some theoretical parts around Gen AI. Where is the Gen AI nowadays when it comes to quality assurance and testing? Before deep diving into more practical examples and do the actual parts of the demonstration in the workshop. We'll talk about comparing GitHub Copilot or Microsoft Copilot versus ChatGPT. Of course, there are a lot of ethical parts and a lot of security, let's say, parts that a lot of companies nowadays are actually concerned about, and the bias and the security, everything is really, taken into account, especially when it comes to use Gen AI for software testing. We'll see how we can actually generate some real-time test data, and we'll conclude the workshop with a practical example, not of using Gen AI, but what the traditional machine learning can do when it comes to implement a self-healing mechanism for our UI functional tests. And this idea that we're going to present in the workshop, it's actually an idea that a lot of companies are using, the modern Gen AI tools to provide solutions that can solve challenging problems. And when it comes to Selenium and UI automation, UI functional testing, we're going to talk about the challenges before jumping into the practical examples. Any questions? I think it can come after the end of the nice workshop. So starting a little bit, you will see this diagram over here. Let's say some history about machine learning, right? And machine learning and Gen AI and what's the future that it's coming towards us. So if we analyze this journey, ever since Agile came into the picture, we'll find that the ways of software delivery have completely changed when it comes to delivery, and we're not talking about only testing. Back in the days of 80s and 90s, we had the waterfall methodology. Everybody's aware. Each team were operating synchronously, not asynchronously, and delivering to the next team. And we had a flow that takes a lot of time. We know about that. Then in the 90s, early 2000, you see that we start experimenting with solutions. This is when a lot of actually ideas around software testing and automation came into place. It wasn't so mature, but the quality assurance strategies started to change. Of course, today it's completely different picture of what it was in the past. So they once in the past trying to keep up with all the changing requirements of the software development and the delivery uploads and the cycle. The present case, we have continuous testing, we have a dominance by the agile practices, we have the CI/CD approach. Even after being denoted as one of the most developed stages of software testing, using artificial intelligence, continuous testing brings some key challenges when it comes to quality assurance processes. We have siloed automation, we have absence of end-to-end requirements visibility, we have a very high volume of tests and test cases. So in order to be able to solve this type of issues, the industry must move to a more autonomous testing, which is the future, and how we can actually use machine learning efficiently, and of course AI. We have generative AI nowadays. Also, the QA world is revolutionizing around the generative AI, which is a game changer for actually the industry. So at its core, for anyone that is not aware, but in this conference we are going to hear a lot about this, it's an AI LLM model which is capable to generate novel and valuable outputs. We can generate test cases, or we can generate more real test data when we're testing against our software applications without having explicitly any human interaction around this. So this is the way that we want to do a more autonomous system, and we need to have autonomous creativity as an enhancement in the testing scope. And this is a potential that we can generate context-specific tests and reduce the need for human intervention. That doesn't mean that people are going to lose their jobs or whatever, but the testers and the QA world can actually focus on more critical aspects of our project, and they can automate as much as possible. That was a challenge when we started even with automating and having all these automation frameworks in the past, but you needed also engineering capabilities around using these tools. Now, with what GenAI is trying to do is you want to avoid, but that doesn't mean 100% avoid interacting, because someone needs to train the model, someone needs to do the heavy, let's say, development around it. So while the idea of having GenAI, it's a little bit daunting due to the complexity associated with the AI models, understanding the basics unveils the massive potential it holds for QA. It's the power to create, adapt, and generate quality tests tailored to the specific needs of a specific system or a specific feature of the system. And we're going to see how we can use today in this workshop these systems. Now, some features which we possibly all, everybody knows about this feature is reusing test cases. It's one of the feature. So the complex process of developing well-written test cases and reusing them for future is made simpler through a lot of AI-based automation tools nowadays. These tools are inspecting our application, and it can gather some general aspects and possibly generate valid user journeys. They can measure loading times, running these tests. They can analyzing basic UI elements, etc. Intelligent requirement gathering, another aspect of these tools. During requirements gathering, there are a lot of manual functions like reporting, managing the impact of the change, tracking approvals, impacts the project deliverables, right? So AI-powered requirement gathering, it can understand the limitations of a complex system we're trying to test. It can track key metrics and KPIs that can be used to predict the quality of our system proactively and performance issues that may have. Simplified exploratory testing. You can use the tools to do more efficient testing with fewer resources, maximize the coverage that you have. It can identify those scenarios easily and can actually, with the through intelligent assistants, which are the AI agents, if you heard about that, they can capture test data and user performances by steering through an application or system, and they can record all these user journeys. Error identification, which is they can leverage the AI-led QA to unearth defects beforehand. They can optimize testing. They are here to optimize how we can predict failure points. So we can reduce costs, we can achieve higher customer satisfaction. That's the whole thing, right? AI-powered visual UI testing and monitoring. So artificial intelligence amplifies test platform with visual testing proficiencies. There are a lot of tools nowadays. There are a lot of brands that they are using AI to do visual testing and have more visually perfect web apps, which back in the past you couldn't imagine that there is also an application of a tool that can do this. Maximum code coverage in limited time. You can actually have multiple use cases generated and cover a lot of user journeys in a fewer time, let's say, and boost productivity within your teams. And of course, faster decisions with AI. We can get more faster decisions around issues, identify root cause of these issues, and how they are impacting the performance of our business. In the next path, you'll see again the historical, let's say, parts of how AI can predict characteristics of a specific release. So software testing takes time as it involves the development of a test suite, so as well as the generation of test data to use with the tests. Furthermore, there are high chances of human errors in manual testing, which can even cost more money and more time from the companies. It's not what the companies needs right now. Also, the number of tests inevitably it's going to grow. You have new features coming in. You have more heavy development, so you expect your tests to grow at a similar pace. So AI can be leveraged to transform our business, overcome all these challenges, accelerate the testing process, see how not only use it for specifically in generated tests or the thing that we saw earlier, but you can actually use it to improve your code base, improve your frameworks, your testing tools. We'll see much examples around that later on. So, um, furthermore, the QA teams can leverage, they can use the API testing tools for supplementing normal testing efforts, right? So while getting the best test coverage in a shorter time period. If we explicitly talk about the test cases of AI in automating quality assurance, here are some ways that testers are using AI presently. They are implementing AI through image-based tooling, determining whether to run a test script or not. They monitoring KPI testing, and they overall trying to automate tasks. Now let's talk. We talked a little bit some of the features of known AI tools in the market, and let's talk about the potentiality of Gen AI. And this is part of the workshop. Um, the potential of Gen AI to revolutionize QA is substantial. We have seen a lot of changes in the past months. They are offering an array of benefits that are promising significantly to enhance our testing process. Yet, as with any transformative technology, the journey towards fully leveraging these advantages comes with its unique set of challenges, and we're going to talk about these challenges. First of all, let's talk about the benefits, right? Reducing in manual labor. We said earlier, we need to reduce. One of the primary advantages of Gen AI is to learn our system, try to adapt testing and quality, and try to automate this process in order to reduce the necessity of repeating, let's say, manual testing or even automation testing that being written from our engineering teams, which is especially beneficial for areas like unit testing, regression testing. Um, this automation doesn't just save valuable time and resources. It allows, as I said, QA professionals, they can focus on more complex tasks than the basic repetitive tasks. Increased test coverage. Generative AI can create a wide range of test scenarios, can cover more ground than traditional methods. You have increased coverage than just using some of your QA engineers to cover everything or as much as everything they can do. Consistency in test quality. So they provide a substantial, let's say, level of consistency that are very challenging when we want to achieve it manually. You need specific people with specific skills to do that. So by leveraging AI, the businesses can maintain a high standard of test cases. Therefore, they can minimize human errors as much as possible. Continual learning and improvement. The models are there, but they are improving themselves based on the input, right? You are using to train them. It's especially beneficial to understand how in traditional machine learning, we'll see by the end with a Selenium example on the workshop, that how you can create your own way and implement your own way to train a model. This is what the Gen AI are doing internally on all the LLM models are using as a fundamental concept. Integration with continuous integration, CI/CD pipelines. Gen AI should be very easily plug and play with your CI/CD, simplifying and automating your delivery process as much as possible. But as we saw, there are a lot of challenges down this road. Some of them, irrelevant tests. They are not trained well until you use people to train these models. There are tests may be irrelevant to your business and your context. There are computational requirements, specifically if you want to run your own, let's say, model, your own, let's say, LLM. This needs a lot of resources. Adaptation to new workflows. So you can, existing teams may require more training to effectively use the Gen AI tools. They need to do, more effective, training around prompt engineering and how they can use these models to achieve the best outcome. Dependence on quality training data, you have the effectiveness of these tools means that the quality of the data that you are using to train them, they are not biased, they are not poor data, because they can result on inaccurate tests. Interpreting AI-generated tests can be challenging as well, especially when they fail. You need to know why they fail, or what's the reason behind it, especially if everything is fully automated. Sometimes it's really challenging to do that. Now, this is the GANs, if you are aware, are the generative adversarial networks, are any type of AI model that can generate new data that resembles the input data. In the realm of QA, this could potentially be used to generate a wide range of testing scenarios based on a specific existing test data. The transformers, like ChatGPT or GPT-4, are another form of Gen AI. They excel in understanding the context and the sequence within the data. So they make transformers particularly useful for tasks like, I want to complete my code, I want to generate some few tests about my context based on some input, based on some description. This is the prompt engineering we talked about. They can read and analyze better. And the variational autoencoders that are actually having two components, the encoder and the decoder. The encoder takes input data, compress, and the decoder takes the space representation, generates new data. So they are, this is how they are being used. So in the general framework for reinforcement learning, an AI model learns to make decisions by interacting with its environment. So it's learning about the environment, the state of the environment, it's training itself, and it can actually generate tests and testing scenarios for more complex scenarios. This is the overall reinforcement learning. Now, we can deep dive, but I don't want to deep dive because it's not the meaning of this presentation. It's more about seeing the practical examples. But this is 7 steps that you can actually create a successful computer vision POC. And computer vision is one area that heavily can benefit QA. It can especially be powerful for QA. For example, you can build your own visual solution. You can do much clever UI UX testing, which is a game changer when it comes to make more visual perfect applications. So as Gen AI continues to revolutionize our QA, it raises concerns around ethical considerations. As I said, to build your own LLM needs a lot of resources right now, and the company doesn't have. Going to the cloud solutions raises concerns about security. There are a lot of other ethical concerns, access that you have. So different business domains that are very, let's say, critical, that you cannot just use this easily, right? Now let's go to the practical parts of our workshop and see how we can demystify Gen AI in the context of QA. We can break 3 categories here: generating examples based on description. A lot of engineers using these tools to actually describe how to test and providing also pieces of code, which is the part of the security we said concerned, like if your application is like sensitive in terms of your data, you need to know how do you operate in this part of the security with the provider of the Gen AI, which, for example, it's OpenAI, for example. The code completion, generating individual tests based on description. It's super nice that we're going to see some examples today. For instance, OpenAI ChatGPT can be used to generate an example test in a specific programming language based on a brief description. Again, as we said, we need to train your QA engineers how they can actually describe the way that your model is going to use to generate your test cases. So, for example, one tester can say, just create some test cases around my login process or my checkout process. The AI can understand the requirements and can produce an example test case in whatever language you have in your code base. So also we can use it when we are developing code, which is extremely powerful. GitHub Copilot being used from millions, I don't know, thousands or millions developers around the world right now in an everyday manner to build their code efficiently, inspect their code quality, generate code snippets, on existing code and potential prompts. Lastly, Zen AI can be employed to create complete tests based on these descriptions. For example, I can have a full end-to-end scenario saying develop a full test case for a shopping cart checkout process. So the AI would analyze the requirements, generate the necessary code, and design test environment. So all of that while minimizing human intervention. What's now the flow of using this? Incorporating AI and transforming your QA strategy requires very careful consideration and planning. There are some steps here. We need to define goals first. You need to identify what you are trying to achieve using these tools in your QA process. This can range from just improving your test coverage, reducing the time spent on manual testing, enhancing the detection of bugs and vulnerabilities, or you can have a combination of all of this. Understand your testing needs. Not all applications or all software solutions can benefit from GenAI testing in the same way. You need to understand the needs and the challenges of your testing scenario. Assess your infrastructure. As I said, it's very important. Don't overreact with that. Choose the right tools to do this. Define the goals. Train your team. With these tools. It's a whole new world for the QA, so you need to make sure that QA have the needed capacity and the skills to work efficiently with these AI tools. Implement and monitoring. This is actually, iterations that you must have within your QA teams. The part of the workshop now is to see how we can use GenAI to do code completion in React. I'm particularly excited because most of the people React Native. It's one of the things that a lot of companies are using for their engineering in their development nowadays. And let's see an example how we can use these tools and compare the outcomes of these tools all together. So this workshop will explore how we can use Microsoft Copilot, ChatGPT, maybe GitHub Copilot, and see what the outcome is, how they are actually doing when it comes to a real life example. So for that, you can scan this project. If you scan it, there is the React project that we're going to use today. And we can start from the slides. So what I'm going to do is first we need to call the Copilot. If you cloned your project after the workshop, try to follow a little bit step by step. Open your Copilot. It's free, by the way. It wasn't, but now from GitHub you can actually integrate Copilot, which is a huge benefit right now. And let's see how we can actually use Copilot in a real life example, right? First, what I'm going to do, I need to share my VS Code. For that, you need to give me a moment. Okay. Yes, I think I need to share my VS Code. 1 second. Right. So I will increase a little bit to see my screen efficiently. In the top, in the bottom right, you will see the ChatGPT. So you can open the chat. You can actually run it all together, but open the chat and start, making questions. That's the whole idea. Even for Copilot, we'll see the example to use it together with the ChatGPT. The first thing to understand is that we are going to uh, use Copilot in order to generate tests. That's the example of the workshop. So what we want to do is we want to find the tests that we have, and particularly, I'm going to open these tests. I want to write a test for emoji picker button. Let's open the React component for that. So let's find not the drop down, this one. All right. So we have a React component, and we're going to see how in GitHub Copilot we can generate some tests around this. Let's see, we don't define which framework we are going to use, but we are going to ask write tests for emoji picker button. All right, so Copilot can identify which one we are going to use. They are using it's using a reference. It's generating our test. By default, it's using the React native testing library. So even if you don't say to the engine, what to use, it will pick up the default one, which is the React testing library. If you see also as well is in earlier versions of the tool, it couldn't understand how to mock things out of the components. So here it can mock as well. It uses Jest. This is the most well-known frameworks for unit testing and component testing in React Native. We see that it's trying to render the component, the React component. So it's checking things on the render side. It's checking the functionality of the button if it is disabled. Shows emoji on button press. So it's also testing some actions on the React component, which is pretty cool. And hides emoji picker on button press when picker is visible. So you see, it gives a good um, capacity when it comes to generate. It generated 4 tests. It's firing also JavaScript events on the React component without any additional, let's say, moment. So if I open my Microsoft Copilot, because I have it in my, let's say, in my environment, let's go to Microsoft Copilot. A second. The first thing you need to do, which is poses a concern, you need to, which I'm not sharing. 1 second. Stop sharing. Sorry for that. And then I need to share again my Microsoft Copilot. So here, what I'm going to do is first you need to copy the whole code and import in your Microsoft Copilot or ChatGPT. So what I'm going to do is, can you please write some some tests for the React component. So, what I'm doing is we need to provide the code, which is the part of the security. A lot of companies are, concerned about sharing the code. Of course, this is a testing code. So what I'm going to do is I'm copying the code, the entire file of your React component, because I want to generate tests around this. And I'm going to my code, to open my browser, and then I'm providing the code. So it's sharing. Let's see what tests by default Microsoft Copilot is providing. You'll see again it's using Mox, it's using React testing library by default without saying anything. It identifies and it's actually running 4 tests in total, which is exactly the same number that we had with the Copilot as well from GitHub. Rendering, disabling the button, showing emoji picker button, hide. So the new thing is that they are having an extra test. Doesn't show the emoji picker when button is clicked and is focused is false. So there is an extra coverage when you are using Microsoft Copilot. The same goes with ChatGPT as well. So let's go again. Sorry, I missed that. So the first thing to understand by default, without saying anything, is generating a very good substantial coverage on your React component. Now, let's see if I want to run the same thing with a UI functional test. Let's say I want to run a Selenium test for this React component that renders on a browser, right? A Selenium test for the React component, which is not the one that I was expecting. Sorry, I need to go to my previous prompt. Yes. Can you write Selenium test TypeScript for the React component? So the steps that Copilot is providing is using in TypeScript. It says how to install your types for WebDriver, and it gives an example. It identifies the React component properties, and it can identify that there is a button with ID, and it uses that to actually render the same test case that we saw for React Native is being used also for Selenium. Should show the emoji picker button when button is clicked, should hide the emoji picker button when button is clicked again. So we see a variety of test cases in Selenium. If you ask this, can you write in Playwright the same? So let's see how it goes. It says how to install Playwright, and you see again a quick example how to write in Playwright and what test cases it can identify. You see with before, it's actually the same test, but now it's changed the framework that it's using. Cool. Let's see. Let's see the same example now, how it goes when we're using our GitHub Copilot. So I'll stop presenting. Sorry, I'm going back and forth, but it's really important. Share and go to my code. So let's ask the pilot, write Selenium test in TypeScript for the component. Okay, so I'm using the same to just write a Selenium test. Um, let's see what is right test. Okay, right Selenium test. Yes, sorry. So here, um, hmm, for some reason, it's not generating well the test, which I'm not sure why. Let's ask again in maybe in a new chat. For some reason, I'm saying write a Selenium test in TypeScript for the React component, but it's messing up with my previous one, which I'm not sure why. So let's open. By the way, on GitHub Copilot, you can refer directly to the use also the Copilot from inside the class, and you can do some fixing, but it's not for the quality. It's more for the engineering team. Generate tests within your, let's say, class file, and everything will be there. But it's really tricky generating for some reason. It's very interesting. Why? But we have seen that a good capacity. There is both advantages in terms of using Microsoft Copilot, ChatGPT engines, or GitHub Copilot, right? But I want to again go back and share the outcome of this. It's very basic, so stop sharing and share my presentation. So using ChatGPT or Microsoft Copilot, for that reason, we can understand that there are different things over here. There are, of course, some advantages. There are some disadvantages. One of the advantages is that we have a rapid idea generation. It can quickly identify a lot of areas to cover. We have some scenarios that can be also, more complex when it comes to React testing. We have a variety of scenarios. You see a wide range of scenarios that we have generated. So it's not like a poor tool for test coverage, so it can improve test coverage. Assistance in designing tests and quick prototype. Like if you have something that you want to do a POC and just do a prototyping using Microsoft Copilot or ChatGPT is actually really quickly. Disadvantage is the lack of domain. It doesn't understand well. It cannot hooked up in your entire application right now. You cannot like just upload the whole code base, and tell it to write tests for your application, or you cannot just, assign to the Copilot to understand how to write tests for a whole application running publicly, let's say. The quality of tests may be tricky, but we show that the quality is really well when it comes to lower level of tests like Selenium tests or React Native tests. There is some inaccurate suggestions, maybe sometimes, regarding the quality of the tests, but it's standing up very well. And what the future holds is that we have Copilot X that is coming with more details. They are using, it's based on OpenAI's Codex. Copilot X will use GPT-4. It's more powerful, from GPT-3, which is the engine. We have Test Pilot from GitHub next. There are, and we have as well local LLMs. They're trying to deploy an LLM locally. Now it's like, you need around 300 gigabytes just of RAM to deploy a GPT-3 model, in your local infrastructure, which is huge amount of resources. Um, as we said, privacy, it's one of the concerns. That's why, deploying LLMs in your infrastructure is the most efficient way, which is, again, prohibited right now. And as you saw, you need to copy or have access to your entire infrastructure and application in the cloud versions of these tools, which makes them a concern for your privacy. You can generate real test data. It's another use of Gen AI. You can actually use them to generate things around using real-time data more efficiently. And we don't have much time to spend on this because I want to cover the part of the traditional machine learning. Um, we're going to use Selenium for making sure we are emulating user interactions. This is the framework of the workshop. Why we use Selenium? It's very well known. It's a tool to manipulate and actually simulate actions in your browser, in any browser type or any mobile device nowadays. First thing, you need to install your dependencies. In this slide, we're going to use Selenium WebDriver together with JavaScript. So, just use npm. I'm not going to run this example of the real data. I'm going to pass it very quickly. Download Chrome driver. Everything is there in the presentation. Hopefully, I will send the presentation to have it as a reference to run your workshop, step by step. And now you just copy this in a JavaScript file, and if you have installed Selenium WebDriver through Node.js, you need to have Node.js installed, of course. Just copy this, and you can actually create a web test directory. I have it already. You can copy this, and they are very informative. You can find an element in your page using this, quick example. Gen AI can help generating random data as well. It's not only generating test cases. You can also want to generate data. You can use Faker, like libraries like Faker, to have fake test data. But eventually, you need more realistic data, and these tools are actually being used to do more realistic data, like Google AI generative language. This, you need to have your API key and the model name, and you will see that if you use this, you can create a client and you can generate more, let's say, real test data for your application. This is one example. I want to use this to get user details. So my prompt is generate the first name and the last name for a person living in Canada, because my users are based in Canada, for example, in my application. So I want to have like a random generated test for something that I don't have any clue or idea of the context of this data, for example. IntelliNode is just another example. It's a Node.js SDK, which is the same, but it has a different engine behind. Now let's go to the final part. We have around 10 minutes to finalize the workshop. Let's see the self-healing tests with Selenium and machine learning. Now, Gen AI is coming originally from traditional ML, right? And we haven't seen like machine learning practical examples when it comes to quality assurance. But they have a different purpose from Gen AI, but what we're trying to do is to create a model to do our own predictions. So if you have a team of machine learning engineers, they can actually really be useful to help your QA team advance the way and implement their own, let's say, machine learning types. We need to understand the problem, what we're trying to do, right? This is what we said earlier. And when it comes to the problem on our quality assurance domain, is that functional tests, specifically UI tests, are tending to fail, quick when we do changes on the UI. Front-end engineers are changing the UI. The DOM is actually changing. We can change IDs, class, the whole tree of the DOM can be fully changed. Why, breaking our tests, right? And why not making an efficient way to identify and predict the best routes on our UI for these tests? And this is what we're trying to do is we're going to create a Selenium bot with machine learning using Python to identify changes on my UI, do predictions, and train the whole logic, right? So what you want to do, I'm going to use Python in this example. You need to install Python, have all the steps, install with pip install Selenium. You need to install Selenium. This is the full life cycle. You need to create your model, deploy, gather data first, prepare the data, do data wrangling, analyze the data, train the model, test the model, and do after the deployment. This is a whole cycle of, let's say, machine learning or traditional machine learning. Now, the concept for our test is that I want to scrap my data from the DOM, store them to local files, and this will be the data for training our model. And then this model is going to be used to predict elements that are changing in the UI to do a self-healing mechanism. Really, it's really, really great. All these steps are followed here. Download dependencies. We use Pandas, which is a Python package for data structures. We use scikit-learn, which is a machine learning library. We are going to build our model, and this is the library that we use to do that. And the NumPy, which is just a library that we use for arrays. Now, the first step is to scrap data from the DOM. So here in this code example, I'm going to run it in a while. I want to take some elements based on specific attributes and store them on local CSV files, because I want to store my test data for implementing the solution. So I'm going to stop presenting and going to VS Code. Share screen. Right. In VS Code, I have already written, and it's part, I think, on the branch, on the main branch, you will see this example. I don't want to write it from the beginning. I created this based on the TechnoJam conference. So what it's doing is I'm using Selenium in Python. I created a function to highlight the elements on the browser that we're going to actually use. Navigating to the TechnoJam register page, and I'm taking all the elements that have input fields. So if I go to this, let's say, example, if I actually don't see my screen because I'm not sharing the whole screen. 1 second. Entire screen. Yes, now you're about to see. So I'm going to the register, and there are a lot of input fields over here. If I inspect them, you'll see this is of type input. So what I want to do is I want to get all these input fields with the respective attributes of ID, name, and these another attribute area described. And I'm appending them into a CSV file using the Pandas library to actually create the CSV file. So if I run it with Python 3, yes, I have Python 3. Sorry, I need to open another terminal. I go to web tests and run my TechnoJam data out, right? So this will actually run. You see here, it's opening the browser. I'm going to highlight all the elements of the solution. So it's going to highlight elements and store all the elements with their respective attributes in the CSV file locally. Why? Because I want to actually scrap, as I said, all the DOM to my file. I want to have all the elements of my page. And you will see behind me that I'm logging also the respective elements of the array. So it's an array. I'm using Pandas to just create a CSV. Now, in the end, the CSV file should be created when it's finished. It takes some time. And let's go before, which is the real implementation of our model. So here, you will see also, I think it's created. Let's go. Yes, we have the output CSV. Sorry, this is the target. Yes, the output CSV. Sorry again. So we get the elements. We get, this is the, I think it's one of the attributes, the name. This is the, no, this is the ID of its attribute. You have the name. And this is actually the CSV comma separated values for all the attributes of my elements, right, in the page. So I have this data because I'm going to use it to train my model. Now let's go to the actual model, which is this class. Again, you will see now I'm simulating a failure in my script. What I'm trying to do is that, let's say I have a change and there is a new name attribute for a specific element in my UI. I'm going to catch the exception here. I'm going to read my data from the output CSV. And I will create another one, which is the target CSV. It's an element that it's predicted from my model, that it's the most closest element that can be used from my automated script to actually self-heal my Selenium test. But there are a lot of details over here, like we create a dictionary of elements for my model. There are three factors when we are training the model. It's the Y train, which is things that we're trying to predict elements, and the X train, which is the part of, these are factors that we use for the scikit-learn to create and run your tests. Of course, you need a random forest classifier. This is actually a way, the forest classifier is the way that you, if I go to my presentation, I have already describing this. This is the random forest classifier. This being needed, it's really extremely useful to understand how to predict. This is coming directly from the scikit-learn. It's a type of model for classification and regression. So machine learning engineers are really aware about this. It's the simplest, let's say, model that you can use for your Selenium test, and that's why we use it as well in our example. And now you can implement the function that it's predicting based on the dictionary and the data. It's predicting which element it can use. And here you will see it's going to predict the element exactly based on the classifier, which element is close to the one based on the input data we trained our model. So if I run the registration, okay, techno, yes, I think I cut something. So if I run my registration, failing a specific element, I'm going to see if, my prediction model is correct, and it will predict the correct element, which is closer to one. So you see in the end, in the output, we get a set of, let's say, tests. And for that, we have a predicted element, which is none. Interesting. We don't get a correct prediction. I need to rerun it again and see if we have, because the last time it was correctly placed. Let me run one time again the registration and see if we are okay. Otherwise, I need to recheck after the workshop. But it's correct. I'm going to fix it. No, it's Possibly the input data are not gathered correctly, but I'm going to push it. What it's going to do, it's going to predict that the element is the one with the correct attribute name. Hence, it can actually self-heal and you can actually continue your test execution efficiently. So this is actually, we are coming to the end. Sorry for that. We're going to share a lot of details after the conference. I'm going to share the presentation. Any questions are very welcome. I'm going to update the code base with the fix. I think it's something which is breaking in the input data. But you will see that with this, you created your own machine learning model in your own self-healing mechanism for your tests. So thank you for attending my talk in my workshop around how to use AI efficiently in a QA workflow.